Okay, so today let us start with the next test portion, that is test 9.1B. This includes these four questions: B4, B5, 6, 7, 8. Okay, let us start with B5. Let me read the question for us here. A kite is flying at a height of 60 meters above the ground. Okay, the string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string, assuming that there is no slack, that means no bending in the string. So there is a kite here at a height of 60 meter above the ground. So let us say the kite is A and the ground level is B. So a string is attached to the kite and touching the ground at C, let us say. And this question is saying is string making 60 degree with the ground horizontal. So this will be 90 degree. Find the length of the string, so AC. Okay. So we write in the figure here, as we read the question, this is very clear to us that AB is equal to 60 meter is the height of the kite, okay? Height of the kite above the ground level, okay? Height of the kite above the ground level. Then the required value is AC, question mark, is the length of the string holding the kite in the sky, okay? Then angle ACB is 60 degree, is nothing but inclination. Inclination means angle, okay? In other words, angle. Inclination of the string, okay? String of the kite according to the language of the text with the ground or the ground level. So with this information, we have to find the length of the string AC. Now in the beginning of the chapter, in the introduction, we learned that in one or two right triangle in this chapter, if one side is given 60 meter or AB and one acute angle C is 60 degree, can easily find the two unknown side. Here the unknown side is this one, so we write that triangle first, right triangle ABC, the length of the string unknown AC by the known height given in the question, we write in the denominator. That way we find it easier, so that is hypotenuse by AB is opposite. And what is the name of this ratio? Yes, that is cosec, and the angle is 60 degree. So that will be AC by 60 meter, because AB is 60 clearly given in the question. Then cosec 60 degree is 2 by root 3, right? 2 by root 3. So next, don't shift AC, we want that. Then shift this 60 from denominator, it will go up and multiply 2, so 62 is 120 by root 3, and meter also will come up from here. So we know now that if you have an irrational number like root 3 in the denominator, we can easily remove them by multiplying by the same one here, root 3 up and down. Then 120 into root 3, 120 root 3 here. Root 3 into root 3 is 3. This meter can be brought back. So 3 4s are 12, 0. So the length of the string is 40 root 3, right? So you can write that down if you want, or that also will be okay. Then next B5, we will go to B5. Oh, sorry, B5 is done just now, sorry, B6. Let me read the question for us. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So there is a boy here, very clearly mentioned. Let's say the boy's height is AB. It is clearly 1.5 meter tall. So there is a building on the right, on this side, one side, and the height of the building is 30 meter, very clearly mentioned like that. Yes, 30 meter. So from here, this is his eye. He look at the top of the building, means the building is taller than him now, so he's looking above his eye level. So elevation. For that, we have to draw a horizontal line through his eye A. So this elevation was 30 degree in the beginning. Then he walked closer to the building, maybe up to here, let us say. So the boy is here now. This is his eye here. This same height, the boy. Same boy. He looked at the top of the building again. And then this time the elevation here, horizontal line and the line of sight increased to 60 degrees. This happened when he walked a distance from here to here. So what is the distance walked? Means this one they're asking. So let us complete it. C. Let us say this is D, E, and then this F, and this point here G. So we have to find BC, the distance that you walked, so that the angle increased to 60 degrees. Okay. So let us write here in the figure, okay, that we have drawn just now. Here, AB equal to GC, because this is the same boy, right? Just changing position. So he will have the same height, whether his position is changed also. So this is the height, okay, height of the boy, height of the boy, okay, height of the boy. Then we will settle something here because we'll need it, but we also know AB will be equal to ED, because we know opposite, okay, because we know opposite sides of a rectangle are always equal in length to each other. What do we mean by that? We mean here we can clearly see A, B, D, E is a rectangle. So A, B, and D, E are opposite sides, so they will be equal. That's what we mean. So that is very obvious now that if AB equal to GC already, we can write that, and both of them equal to 1.5. But AB is also equals this one equal to ED, so we can combine the two because all of them are equal now, and 1.5 meter. We will need that, so just keep 1. Okay. Then next here we will think like this. Here BC, we write here BC is equal to question mark is the distance he walked. That means the boy walked towards the building. The question says that like that. Towards the building. Okay, towards the building. This is what the question is asking us. Now next, the angles of elevation they are 2. So we'll just write them as under a heading, angles of elevation. Okay, angles of elevation. First one, he stands at this position, so angle FAE, this one here. FAE 30 degree. Then he walked closer, FGE becomes 60 degree. Okay. With this information, we have to get this BC or AG, the distance that you walk towards the building. Okay, so we know these are 90-degree points. So we know surely this is a right triangle. Now let us focus here, this line once, and this is 30, but this is unknown. Let us try to find this, because if we get FE is the side of this right triangle and also the side of this big right triangle, because it's a common side, and will help us to get these distances here, which will help us to get BC. Okay, so in right triangle GEF, small one, let us, okay, before that, let us find, let us find out FE. Okay, so here FE, let us focus on FE is simply FD minus ED. You will agree with that, right? FE is FD tall one minus ED. Now FD is 30 meter minus ED, also we already have 1.5. That's why we're doing that. And we write here, since using equations here, equation one, and knowing that, you know that from the question that height of building FD is written in the question as 30 meter. So this is your reason. So now 30 minus 1.5 is 30.0, 1.5 minus plus, so here 5, 1 is taken, so 9 minus 1, 8, 1 taken, so 28.5. This is the rough portion, 28.5 meter. So let us keep this one as equation number 2, following the 1 there. Okay. So now, once you get FE, that is now advantage. It's the side of this triangle GEF. So you can mention that now in right triangle GEF or FEG, up to you. Okay. We want GE, so write that GE divided by FE is known now. See here. So known side down. What is that with respect to 60? So adjacent by opposite, so that is cot, and the angle is 60 degree. So that way you can write here GE by FE is here 28.5 meter is equal to cot 60 degree is 1 by root 3. We know this from previous chapter table, right? So that is GE, don't move, keep on the numerator. We shift this 28.5 from denominator, it will go up and multiply 1, so 28.5 by root 3, and meter also will come up. So we need to remove this irrational, we know that immediately, so 28.5 by root 3. How do we do that? We multiply by root 3 up and down. So when we do that, 28.5 into root 3, 28.5 root 3, and root 3 into root 3, 3, no more root. So that is called rationalizing or removing the irrational sign from the denominator. And meter can come here. So 3 ones are 3, 3 nines are 27, 1 in hand. That one will go behind 5 after decimal 15. So 3 5s are 15. So your value for GE is now 9.5 root 3 meter. You can keep this one as the question number 3. Okay, 3 following this 2. Now here we forgot to mention, but you will give the reason, since using equation number 2 we are putting this value FE from equation 2 here. That's what we mean. Okay, now you got your GE. So by the same technique, you take a big one now, and you know FE, not here, FE. Use that to find AE. So you find AE, then minus this one here, GE. Look at the diagram, that's your answer. Here, AE minus GE is AG, which is the distance walked, right? So that's what we're trying to arrive at. So here, in the other big right triangle, in right triangle, F, AEF, whatever, AEF, you want to find AE. So write that on numerator by non-value is FE. So write that one. As you can see here, FE, so you write that one, is equal to here adjacent by opposite again, so cot, and the angle this time is 30 degree. Now AE by FE in equation 2 is here 28.5 meters, so write that, and cot 30 is root 3. So you write this AE without shifting and shift this denominator, it will go up and multiply and get 28.5 root 3 meter. And here don't forget to mention again, since using equation number 2, we got this FE value from 2. Then next, let us put this one as equation number 4, following the last one, 3. So now, therefore, just write this required distance BC. So write that BC, you notice is equal to AG. On the diagram, you can see that. BC equal to AG, simply because we know opposite sides of a rectangle are always equal in length to each other. See here, ABCG is a rectangle. So AB and GC are BC and AG are opposite sides. So that is advantageous now, because BC equal to AG. That is nothing but equal to AG. Focus on the AG, that is long line AE minus GE. So right here, AE. Why did we do that? Because we have both these values, AE and GE. Okay, so you write here that is equal to AE is 28.5 root 3 meter minus GE here 9.5 root 3 meter. So 9.5 root 3 meter. Then you do this one here. 28.5 minus 9.5 root 3 means you subtract 28.5, 9.5. So you can do that here. 28.5 minus 9.5 is, this is plus, so 5 minus 5, 0. 18 minus 9, 9. 1 taken, so 19.0 means 19 root 3 meter. So distance walked is this one. We got the answer. Okay. Now next question, second question, B7. Let us go there. B7. Let me read the question. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed on the top of a 20-meter building, okay, high, are 45 and 60 degree respectively. So that means there is a 20-meter tall building, and on the top there is a tower. Tower is AB, let us say. So at a point C here from the ground, the person look at the bottom of the tower on the building. Building is BC, okay, sorry, BC and D. D, he looked this one, bottom of the building. Elevation was 45 degree. When he looked from the same position, the top of the tower, transmission tower means that mobile tower kind of thing, I think. So here, so this here is 60 degree. Now you have to find the height of the tower, AB. So this is given to you, height of the building, okay? So we will start it here. In the figure, okay, in the figure, we have here AB is question mark, is the height of the tower, okay, that we need to find. Then BC is equal to 20 meter. I think it's 20 meter. Yes, it's a 20 meter high building. So 20 meter is the height of the building. So you write here height of the building, the height of the building. Then the angles of elevation, two of them are there. The bottom elevation is BDC angle is equal to 45 degrees, and the top elevation of this point is angle ADC is equal to 60 degree. ADC, okay? With this information, we have to find the height of the tower, AB. Now it's quite easy, I think. See here, take the smaller one, right triangle, because BCD has one side. See, BC already there. One side there means you'll find DC. And if you have DC, then DC becomes the side of big one. So if one side of big one is known, you can find this AC. AC minus this 20 will give you the height. See, that's what we're trying to do. So you follow that. Small one first is the right way to approach it. Right triangle, BCD. We want to find DC by given side is BC 20. So that is adjacent by opposite, right? So that is scope and the angle is 45 degree. Then here DC, okay, DC by BC is 20 meter and cot 45 is 1. So DC will be 21 20 meter. Let's keep this one as 1, okay? Then take the bigger one, because DC is now the side of the bigger one also common now to about the triangle. Now we want AC unknown divided by the given side known to us now 20 down. So that will be equal to opposite by adjacent is 10 and the angle this time is 60 degree. So once you get that, this will be AC by DC is here 20 meter and 1060 is root 3. So AC, this 20 will go up and multiply root 3. So 20 root 3 meter. Okay. And you can mention here the reason. I think we should, since using equation number 1 for the DC value here, 20. So this one, equation number 2, you put it. Now you can write here, therefore, the height of the transmission tower AB, common sense also tell us, this one AC log 1 minus this BC already know 20. So that is 20 root 3 meter for AC here in equation 2 minus BC log given here 20 meter. So you write here 20 meter and write here since using equation number 2 and knowing the value of BC to be equal to 20 meter. So the answer is almost done. Okay. So next point here, you can write that will be equal to, common here is 20. So take out of the bracket 20. Inside the root, inside will be there for root 3 inside bracket minus 21 this 20 and meter common. You put it outside bracket back, 20 common in front, meter common back. So approximately the height of the tower here is this one, 20 into root 3 minus 1 meter. Okay, it is done. And final question, you can write that down if you want, or you can stop there also. B8, the last question. Let us do that. Let me read the question. Here, a statue 1.6 meter tall stands on the top of a pedestal. Okay, pedestal means the foundation below the strong foundation below the statue, so that the statue can be held strongly, firmly. Okay, from a point on the ground, the angles of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Okay, so here there's a pedestal, means the foundation below the statue. There is a statue above it. So this A, let us say this AB signify the statue, this point. So here, this is just the reverse little bit of 7, similar, very similar. So it shouldn't be height. The height of the pedestal is unknown. The height of the statue is unknown. The height of the pedestal is given. BC, okay. And if you look into the question, statue is given 1.6 meter tall. This is given 1.6 meter tall statue above the pedestal. Height of the pedestal, we don't know, we have to find. From a point on the ground, let us say D, the person look at the top of the pedestal. I'm doing the second one first, okay, and he found it to be 45 degrees. Then from the same point, he look at the top of the statue. Top of pedestal, 45. Top of the statue, 60 degrees. The question is saying that this is right angle. Find the height of the pedestal. Previously, we had to find the height of the tower now. Height of the building is like pedestal now. So it's very similar, even the values, but the reverse of that 7, question number 7, B7. So here, let us write down in the figure. Now in the figure here, AB is equal to 1.6 meter. This is nothing but the height of the statue. Height of the statue. And then BC is a question mark, is the height of the pedestal that we don't know yet. Then angles of elevation. Very clearly we can see here. First one is the top of the statue, so ADC they mentioned first. It's up to you which one you mention first anyway. Then BDC, the second mentioned one, the top of the pedestal elevation is 45 degrees. So with this information, we have to find this BC, the height of the pedestal. Should not be hard. So look here now. How will we do? Look here. You see here, the 45 one we take first is going to make it easier. So just take in right triangle, BCD. That means the right triangle containing 45. Just write BC by DC is equal to opposite by adjacent, so 10, 45 degree. Then here, BC by DC is equal to 1. So BC will be equal to DC. Keep this one as question 1. So learn to see this. BC and DC are equal. These two are equal. Means in a sense you can just write here BC if you want. So DC to BC as a BC, BC. So that makes things easy for you. In right triangle now, the big one, ACD, the big one, AC, the tall structure by the whole thing, statue plus pedestal by DC is opposite by adjacent, so 10, this time 60 degree. Now very clearly you can see AC can be broken into AB plus BC by DC. 10, 60 is root 3. Continue doing it. AB is 1.6 meter plus BC by DC, root 3. Just keep on doing it. Then here you see, we want to find BC. That's what the question is asking. Now 1.6 meter. So you can write here the reason if you want. AB is given in question as 1.6 meter. That's why we changed this AB to 1.6. The next step, you can write here 1.6 meter plus BC by here DC. We have already learned to see same as BC. See here. So we replace the DC by BC. Why? Because we want BC, not the height of the pedestal, not DC. So everything is now BC now on the left side. On right side is just a number root 3. So you can easily find out by solving now. You can see that. The only thing you don't know is BC now, right? And give the reason here because using equation number 1, where you know BC equal to DC, so DC is replaced by now BC. Multiply this up root 3 to BC and you get root 3 BC. Okay, so keep it on one side, root 3 BC. Then put equal sign. When root 3 means here root 3 by 1 is there, so multiply that 1 to 1.6, you get 1.6 meter plus that 1 multiplied to BC is BC. So cross multiplying, you get that. So bring the terms containing BC on one side. Root 3 BC and this plus BC, bring this side minus BC. The number, you just keep it on the right side, don't shift, so same 1.6 meter. Then common factor here you see is BC, so take out of the bracket. Then inside will be root 3 minus BC into 1 is BC, and here 1.6 meter. So here BC will be equal to 1.6 meter divided by, because this into no sign, then this bracket will come down to the denominator. This into will become divided by. Now here you need to listen carefully here. See, when you have previously like this, root 3, this is called pure surd or pure irrational number, but this is not pure. Irrational number and rational number mixed. So that's called mixed surd. Okay, mixed irrational number. That means, how do you remove the surd in mixed ones? You have to multiply by the thing called conjugate. Okay, conjugate surd. Conjugate means if the mixed surd is root 3 minus 1, then you have to write here root 3 plus 1. Up also same, root 3 plus 1. Which means if this was root 3 plus 1, the conjugate would have been the reverse, root 3 minus 1. Okay. Surely if you do that, this surd will be removed. Irrational sign will disappear. You can see now 1.6 into this one, root 3 plus 1. And meter, you can put it at the back. And then a minus b into a plus b. We know this formula previously also, a square minus b square. So here 1.6 into root 3 plus 1 divided by root 3 square. Square will cut the roots of 3 minus 1 square is 1 meter. Then here 1.6 into root 3 minus 1 by 3 minus 1 is 2, and meter here 2 into 0.28 are 16. So height here will be root 0.8 into root 3 minus 1 meter. So this is the BC, the height of the pedestal. Okay, the height of the pedestal. So that concludes the part for 9.1B. Okay, you can give the test after this.